This tiny bird can remember over 10,000 hiding spots, and scientists still don't fully understand how. Meet the black-capped chickadee, smaller than your fist, but carrying one of the sharpest memories in the animal kingdom. Let's call this one Willow. It's early October, and Willow is working non-stop across a snow-dusted forest, racing against a season she can feel coming. She picks up a sunflower seed, flies to a crack in the bark, and tucks it away. Seconds later, she's grabbed another seed, this time hiding it under a curl of dead leaves. By nightfall, she has repeated this hundreds of times, scattering food across her entire territory. Over the course of one winter, a single chickadee like Willow can create more than 5,000 separate hiding spots. Each one holds just a single seed or insect, nothing stored in bulk. No pantry, no single stash, just thousands of scattered individual bets against starvation. Now here's the impossible part. Months later, buried under fresh snow, with every visual landmark changed, Willow returns. She doesn't search randomly. She flies directly to specific spots, one after another, retrieving food with startling accuracy. No map, no scent trail, just memory. Picture trying to remember exactly where you left 5,000 separate house keys buried in the snow months ago. That's what this bird does every single winter, without fail. So how does a brain this small pull off something this advanced? The answer lies inside a part of the brain called the hippocampus, the same region responsible for memory and spatial navigation in humans. In chickadees, something remarkable happens every autumn. The hippocampus physically grows larger. New neurons are added, existing connections are strengthened, and the bird's memory capacity expands right before the season it needs it most. Then, in spring and summer, when caching isn't necessary for survival, the hippocampus shrinks back down. Researchers call this seasonal neurogenesis, the brain rebuilding itself to match survival demands. Stop for a second and think about that. This bird's brain is redesigning itself every year on a schedule. Dr. Vladimir Pravosudov, a leading researcher on food caching birds, has spent decades studying this exact behavior across different chickadee populations. His research found something even more surprising. Chickadees living in harsher, more unpredictable climates develop larger hippocampi than chickadees living in milder regions. In other words, the tougher the environment, the sharper the memory needs to be. And evolution responds accordingly. A chickadee living in the mountains of Alaska will out-remember one living in a mild coastal climate simply because its survival demands it. This isn't just about finding food, it's a direct survival tool. Winter temperatures can drop low enough that a chickadee must eat almost constantly just to maintain its body heat. Miss too many caches, and the bird simply won't survive the season. For Willow, every single one of those 5,000 hiding spots is a small emergency fund against a night that could kill her. So memory accuracy isn't a bonus skill here. It's the difference between life and death. If a bird this small can out-remember and outplan animals 100 times its size, imagine what's happening in the backyard birds you walk past every day. That's exactly why we cover birds like this on this channel. So before we go further, if you're enjoying learning what's really going on behind these tiny brains, hit subscribe, because there's a lot more of this coming. Now, memory alone doesn't explain everything about how chickadees survive. Because remembering where the food is means nothing if you don't survive long enough to eat it. And that's where chickadees reveal a second kind of intelligence. Chickadees have one of the most complex alarm call systems ever documented in a songbird. Their signature chickadee call isn't just a random sound, it's an encoded message. Researchers Christopher Templeton and Eric Green discovered that the number of D notes at the end of the call actually changes based on the size of a nearby predator. A large, slow-moving predator like a great horned owl gets a call with very few D notes, but a small, fast, more dangerous predator like a pygmy owl can trigger a call with far more D notes added. Why? Because smaller predators are more agile and more threatening to a chickadee in flight, so the flock needs a stronger, more urgent warning. This means chickadees are communicating specific threat levels to each other, not just danger nearby. Other birds nearby, even different species, have learned to recognize and respond to this code. When they hear more D notes, they react with heightened alarm, even before spotting the predator themselves. So picture Willow, mid-flight toward one of her hidden caches, when she hears 3 extra D notes from a nearby flock member. She doesn't need to see the threat. The code alone tells her exactly how dangerous it is and exactly how fast she needs to react. This is a real-time warning network, built entirely on sound, refined over generations, and it doesn't stop at just 2 skills. Chickadees also use social learning, watching other chickadees to figure out which new foods are safe to eat. Researchers have observed chickadee flocks forming loose social hierarchies, where lower-ranked birds actually learn faster because they're forced to explore more cautiously and observe more carefully before acting. In other words, being lower in the pecking order might actually make a chickadee a better learner. So when you combine everything, 5,000 hidden locations, a brain that rebuilds itself seasonally, a coded alarm language, and social learning passed between flock members, you start to understand this isn't a simple bird. It's running a survival system with more moving parts than most people realize. Put memory and communication together, and you start to see why chickadees survive in conditions that kill off far larger animals. They don't rely on size, speed, or strength. They rely on information, stored, updated, and shared constantly. And that's really the bigger lesson hiding inside this tiny bird. Intelligence in nature isn't always about brain size. It's about how efficiently that brain is used. A chickadee's brain weighs a fraction of a gram, yet it out-navigates, out-remembers, and out-communicates animals many times its size. Willow will never know how impressive what she's doing actually is. She'll just keep flying from branch to branch, hiding seeds, listening for coded warnings, and somehow making it through another winter that should be impossible for something her size. So next time you see a chickadee hopping along a winter branch, know that it's not just looking for food. It's running a memory map more precise than most of us could ever hold in our own heads, guided by a brain that quite literally reshapes itself to survive. If you want to see which other backyard birds use hidden survival intelligence like this, make sure you're subscribed, because next time, we're covering a bird that fakes its own death to survive.